What you see on screen is the Global Positioning System, GPS, a vast constellation of satellites that allows a small device on Earth, like your phone, to know exactly where it is. But here's something few people realize. Without Albert Einstein's theory of relativity, GPS simply wouldn't work. Our entire navigation system, the one guiding airplanes, ships, and every car on Earth, would fail within hours. GPS works through a constellation of satellites orbiting Earth about 20,000 kilometers above the surface. Each one travels at roughly 14,000 kilometers per hour, constantly sending signals toward the ground. Your phone listens to those signals and calculates its own position. To do that, it needs very precise information: the exact time the signal was sent, the location of the satellite, and its speed in orbit. At least 4 satellites are always required to pinpoint your position anywhere on the planet. That's why the system uses 24 satellites, divided into 6 orbital planes, ensuring full global coverage, 24 hours a day. When your phone receives these signals from 4 or more satellites, it performs a calculation that allows it to determine both your position and altitude with astonishing precision. But here's the mystery. Why does a system made of simple clocks and radio signals depend on Einstein's theory of relativity? The answer lies in how time itself behaves for those satellites. There are 2 relativistic effects involved, one caused by velocity, the other by gravity. Because the satellites travel so fast, they experience time dilation. Time actually passes more slowly for them than for us here on Earth. Each satellite carries an atomic clock, but because of its velocity, the clock runs slightly slower. This effect delays the satellite's time by about 7.2 microseconds per day compared to clocks on Earth. It sounds tiny, but for GPS, that difference is catastrophic. Now, let's look at the second effect, gravitational time dilation. At an altitude of 20,200 kilometers, gravity is weaker. And according to Einstein's general relativity, weaker gravity makes clocks run faster. So while velocity slows the clock, reduced gravity makes it speed up. This second effect causes the satellite's clock to gain about 45.6 microseconds per day relative to a clock on the ground. 2 opposite effects, one slowing time, the other speeding it up. When combined, they don't cancel out. They leave a residual difference of 38.4 microseconds per day. That might not sound like much, but if left uncorrected, that tiny time shift would translate into errors of several kilometers in your phone's location after just one day. So the GPS system you use every day is not just a triumph of engineering. It's a daily confirmation that Einstein was right. Every satellite in orbit carries a built-in correction, a direct application of the equations of relativity, ensuring that time, distorted by speed and gravity, stays perfectly aligned between Earth and space. Without it, the modern world would quite literally lose its way. And that is how relativity keeps you on the map. If you enjoyed this video, leave a like and subscribe to the channel. See you in the next one.